Welcome to our first screencast on thermochemistry. In this one, this is going to be our intro to thermo. And in this screencast, I plan to talk about different symbols that we use in thermochemistry. We're going to talk about energy, and we're going to talk about some other vocab terms that are related. Thermochemistry is one of the first chapters where we get into the use of Greek symbols and a lot of other variables that we haven't experienced before. So one of the first things that you need to be able to understand is delta, and that's the Greek letter D. And that is a capital delta, and a lowercase delta looks like that. They're both delta. We are going to be seeing a lot of things like delta T, and what delta means is the change. So as we see delta T, we would understand that to mean delta T equals the final temperature minus the initial temperature. And so it's the change in temperature. You can also apply delta to E. So we'd be looking at the final energy minus the initial energy. And so when you see the change, it's really just asking you to compare the beginning and the end points. And instead of giving you a subtraction, they're going to label it as delta and the variable. Some additional variables that you will see E, and E is going to stand for energy. And that one makes sense. Okay, so the energy is E. You can have kinetic energy, and you can have potential energy, and there's lots of factors that can affect energy. So if you see E sub K, that would be the kinetic energy, and E sub P would be the potential energy. Another thing that you would see labeled in thermochemistry is if they're asking you to find the delta H, which you don't know what it is yet, but if they say delta H at RXN, RXN is an abbreviation for reaction, and it is often used a lot in thermochem because you will be solving for a change in enthalpy for the whole reaction. So that would be the delta H of RXN. This Wordle has many of the words that you're going to see associated with the chapter on thermochemistry, and I just want to point out a few. The first one that I want to look at is that we are going to be focused on the energy in the reactions. So we are looking at whether energy goes out or whether energy goes in. We're going to be looking at how much energy. We're going to be focusing on the energy of products and reactants, and we're going to be applying that to chemical equations. So energy is the main focus, and we're going to be looking at enthalpy, which is another name for heat. Okay. So all of these things, energy and enthalpy is a form of energy, and it, along with some other factors, affect what reactions do. Okay, back to the Wordle again. Remember, we're focusing on the energy, and energy is all around us. Energy is everywhere, and inside the world and outside the world. It's in all the reactions. In fact, we need to conserve it so it is not gained or lost. We really need to address, when we're looking at a reaction, we need to address a couple of things. We need to address what we're going to call the surroundings, and we're going to need to address what we're calling the system. So when you are dealing with a reaction in thermochemistry, we need to know what are we focusing on. So let's say this big red circle is our system. So we'll label this as the system. And then that means that the surroundings are everything beyond it, outside of the system. So we could be looking at, if the circle was a beaker, we would be looking at the reaction and the energy in the beaker, and then we would look at everything outside of the beaker and decide, was the energy being put into the beaker or was it being taken out of the beaker, and that would help us define the focus of the problem. Most times when people are asked to consider kinetic energy and potential energy, they often will think of potential energy as a battery. When in this comic down here, you can see both potential energy and kinetic energy. Potential energy is a stored energy. So it is a result of the potential or the likelihood that the energy could be used. So this is stored energy that she is standing at the top of the steps, and she could, in fact, move down the steps, and in likelihood will, step down of her own accord. But here in this image on the right, you see kinetic energy, and this is the energy of motion. And instead of being able to walk down the steps, you see she's falling down the steps. So the kinetic energy is the energy associated that is being given off or taken in for the reaction moving. And in potential energy, it is the energy stored by being at the top of the steps and the likelihood that she will move down. So again, potential energy is stored energy, and kinetic energy is the energy associated with motion. Energy measured in joules, and we abbreviate joules with a capital J. You will most often see kilojoules, and we can also measure energy in calories. And just like the food we eat is measured in calories because it has so much energy, you can equate joules and calories, and it is 1 calorie is 4.184 joules.